Assalamualaikum warahmatullahi wabarakatuh. We from Group 10 will present about Bowstring Structure. Here is my group members, Aflin Zakarilim, Ahmad Faiz bin Abdul Rashid, Muhammad Fahri bin Nasbullah, and Aiman Haziq bin Mozuki. Now let's go to introduction. Bowstring Bridge or Tide Art Bridge combine aesthetic appeal with structural efficiency. This bridge featured a curved arch that carries compressive force and a horizontal tie that resists tensile force, reducing the load on bridge supports and making them ideal for location with weak foundation. The design principle governing a bowstring bridge include the moment of joint, ensuring stable load transfer at connections, and the moment of couple, balancing equal and opposite force to prevent rotational instability. The project aims to design and analyze a bowstring bridge by calculating moments and stress, optimizing material selection, and achieving a balance between strength, weight, cost, and aesthetics, ultimately creating a safe, durable, and visually striking structure. Now we move to background of case study. Truss bridge, particularly the bowstring truss bridge, are highly versatile and efficient, especially for heavy-duty application like railway bridge. Combining the features of a tight arch bridge with a truss system, the bowstring truss use a curved arch under compression and a horizontal tie beam to resist tensile force, while the truss elements evenly distribute loads. This design is ideal for railways, which impose heavy and dynamic stress on bridge. Bowstring truss bridge are durable, reduce horizontal thrust on foundations, and are well suited for areas with poor soil conditions. Used in historic railway system worldwide, they continue to evolve with new materials and techniques, offering longer spans, reduced maintenance, and improved performance. This study examines the bowstring truss bridge engineering principles and its ongoing relevance in modern railway infrastructure. Now, let's move to basic theory. First, efficient load distribution. Thrust transfer loads through axial force, tension or compression in the structural members, minimizing material use compared to beams. Second, static equilibrium. Stability relies on the balance of force in horizontal and vertical direction and moments about points, with methods like the method of joint and sections used for force calculations. Third, truss configuration. Various designs like Pratt, Howe, Warren, and bowstring truss optimize performance under different conditions. 4. Bowstring truss. This design combines a curved top chord under compression and a straight bottom chord under tension, leveraging both arch and truss principles for enhanced load handling. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Faiz bin Abdul Rashid, number metric AA241439. So today I will present real engineering application. So first, for highway bridge, I choose Clyde Art Bridge from Glasgow, Scotland. So why this bridge use bowstring truss? So first reason is aesthetic appeal. The curved art give the bridge a striking and iconic appearances, enhancing the urban landscape. Second, load distribution. The bowstring design allow efficient transfer of highway traffic load to the equipment through the arc and tie, and minimizing bending moment. So last, clearances and navigation. The design recommended tall vessel to pass underneath while maintaining the low profile deck required for highway traffic. Second, application of bowstring structure in railway bridge. I chose Chao Tiemen Yangtze River Railway from Chongqing, China. Why this bridge use bowstring truss? So first reason is high load capacity. Railway traffic impose significant load. The bowstring truss provides strength and rigidity to handle heavy train loads. Second, durability. The structure ability to distribute stresses through its tight system, reduce wear on individual component, increasing longevity. So last reason is space efficiency. The art design minimize obstruction, providing ample clearance for river traffic beneath the bridge. the bridge. So third application, bouncing structure in combined bridge, which is have road and railway in one bridge. I choose Sydney Harbour Bridge from Sydney, Australia. So why did this bridge use bouncing truss? So first, versatility. The design support multiple transportation mode, including rail, vehicular, and pedestrian traffic. So second, robustness. Robustness. The bouncing design ensures stability and structural integrity under diverse loading condition. So last, urban integration. The design maximize utility in a dense urban setting while creating a landmark. So lastly, application bouncing structure in pedestrian bridge. So I chose Peace Bridge from Calgary, Canada. So while this bridge use bouncing truss, so first reason is elegant design. The slender curved structure integrates seamlessly with the natural and urban environment. So second, lightweight construction. For pedestrian use, the bouncing truss is ideal, balancing aesthetic requirements with structural efficiency. So lastly, minimal environmental impact. The design minimizes the number of piers in the water, reducing the ecological footprint. So, for key advantage of bouncing structure in this application, first, efficient load transfer. The arc transfer comprehensive force to the abutment, while the tie resists the horizontal thrust, making it ideal for heavy traffic. Second, material efficiency. By optimizing stress distribution, bouncing thrust reduce the required material volume. Third, architecture versatility. The curve shape allow for creative design while retaining structure functionality. So lastly, spanning capabilities. Bouncing structure can efficiently cover long spans, reducing the need for intermediate support. That's all from me. Thank you.
Right, Assalamualaikum, and my name is Aiman Aziz. My matrix number is AA240 236, and this is the calculation and analysis for our bridge, which is bowstring type of bridge. Alright, for this is our calculation for the truss bridge model that I just draw just now. And for the first step, we find moment at support, which is moment at point A. After finding all the moment, we will find EY. After that, we find the sum of x to find the value of AX, which is equal to 0. And the second step is we find AY by using the method of sum of force at y axis. Right. For the third step, we will start the find of the truss at joint A, because joint A have two separate force, and for the first step we use the sum of y to find the AH, and we will find the AH. And for the AB, we use the sum of x and we will find AB. And after that, we move on to point B and we draw the free body diagram and label as much as information as you can find. And the first formation that we can find is AB equals to BC, because the length is same and the force that act on it is same. Alright, to find BG, we must use the sum of x, right, which is fx equals to 0 to find BG, and the angle that we find for BG is 56, because with the formula TOA, which is opposite over adjacent, tan opposite over adjacent, and then we'll find BG. And after that, we use sum of Fy to find BH, because at first place we already find the BG and we can put it in the sum of y formula, and that we can find BH. Moving on to the point C, we will find Fy equals to 0, which is force that put and act on the point C is 10, and we can find that CG is equal to 10 because Fy equals to 0. And as I said before, AB equals to BC Same goes to BC equals to CD because it has the same length and the same amount of force acting on it. Okay, so the point H, we will start by labeling and drawing the free body diagram and label every single thrust that we found that happened and acting on the free body diagram. As you can see, we already find the AH and HB amount of force that act on it. And the last thing that we should find is HG or GH. So, in order to find GH, we will use the formula of sum of y, which is Fy equals to 0. And then we insert every single amount of force that we can find and make the GH as our unknown. And after that, we will find the amount of GH. And as you can see, every negative amount that we get, we will label it as compression, and the positive amount that we get, we will label it as tension. And the last thing that I will state is
Now, let's discuss about bowstring bridge. A bowstring bridge is a tight arc bridge with a curved arc under compression and a horizontal tie under tension. Its efficient design, redistributing forces, reducing stress on foundation, and using less material than traditional beam bridges. The main key strengths are structural efficiency. Next, let's discuss about the potential improvements. Advanced materials. High-strength steel and fiber reinforced composites can enhance durability and reduce maintenance. Streamline construction. Modular assembly techniques can lower construction costs and minimize disruptions. For sustainability, we can integrate renewable energy features like solar panels, wind turbines. This improvement can reduce environmental impact and also power infrastructures. To conclude, the Bowstring Bridge combines strength, versatility, and aesthetic appeal. It is also advanced in material and construction techniques, provides solutions to challenges, making it a valuable option for modern infrastructure. For the conclusion, bowstring bridges combines gracefully arched top chord, which is compression, and straight bottom chord, which is tension. It is also highly efficient, providing strength, stability, and effective load distribution. One of the main key advantages of bowstring bridge is its structural stability, which minimizes stress concentration, ensuring durability and longevity. It also uses less material compared to traditional designs, reducing construction costs. Uh, Bowstring bridge is also lightweight yet strong, ideal for large-scale projects. It also offers an aesthetic appeal. Elegant curve form enhance the visual quality of structures, popular for projects requiring both functions and architectural significance. Bowstring bridges can also blend well with urban and natural environments. Its versatility and it is also versatile and adaptability, suitable for various spans and load conditions. Pedestrian bridges, railways, highway bridges, it can be tailored to meet specific engineering needs. For sustainability, it is efficient use of materials aligned with modern sustainable building practices. Also, cost-effective and resource-efficient design. For future potential, it is adaptable to advancement in materials and technologies for improved performance. Ongoing innovation positions bowstring trusses as a cornerstone in future large-scale infrastructure projects. To conclude, the bowstring truss balances strength, cost, and also design flexibility. It is poised for continued adoption and innovation in modern construction. That's all from us, Group 10. Thank you.